Okay, here we go. We're going to come back up here. If you haven't finished the quiz, you're going to need to do it another time. If your name is on the board, not allowed in lab next time, you need to fix whatever's up there and fix it before next time. So you either are missing your safety test or your hard copy medical. Otherwise, it will not let you in lab. You picked up as you came in a lab. You need to make sure that the pre-lab is finished and stamped before you leave so you're ready to roll into lab next time. The lab will take the whole period. If for some reason you are not going to be here on Wednesday because of the beginning of fall break, you're taking a day early. That lab is also going to be done during tutorial on Wednesday and Thursday next week. You have to come to both of them in order to get the lab done. Thursday is going to be a tutorial because it's the last week of the term. So it's no longer an advisory the last week of the term. Okay, so that's what we're going to do. We've decided I'll be running it. The other teachers are sending their absent kids there. So just real quick, a reminder, Monday, October 22nd is the last day. That is the Monday after spring or after fall break. That's the last day that you can put in late work for Unit 1 and Unit 2. You can redo quizzes, you can redo daily work, you can redo labs. The only thing you cannot redo are tests and independent quizzes. You can still hand in independent assignments, but you just can't redo the quiz because the quiz assigns you a problem set.
Where should I put the blender? That's all.
Blender goes in a tall thing. You'll see another blender in there with one. So, okay. Don't forget, Wednesday the 24th is the last day for Unit 3 work, and then Thursday the 25th is a term test. So you have to have things done before the test day this time. Okay, don't forget about Science Day at the U, November 3rd. It's going to be an awesome experience, and you'll want to take somebody with you. So here we are, Monday, October 15th. Today we are going to do the pre-lab in green. We're going to do finish daily work in blue and redo quizzes, whatever you need to redo. And then red is going to be help. So if you need help with the independent study, I have printed off some of the independent practices. If you haven't got yours, you just need to know which one you were assigned. And then next time we'll do the lab. Tuesday will be the review. And Thursday we test and we're done with the term. So you're in charge of your grade, guys. Make sure by Monday, because I won't see you on Monday, you've got everything done and in. All right, going on to the PowerPoint. So we should have taken quiz 3.4. If you haven't, you need to do that really after I finish this. We're going to talk about wavelength and energy and light equations and calculations. So when we talk about the electromagnetic spectrum, we're talking about a long range of waves. Okay, we go from gamma rays all the way up to ultraviolet rays. Then we hit this little teeny section here that is the visible light, what we can see with our eyes. Then past that is infrared rays, radar, FM, TV, and shortwave. So wavelengths, we're going to talk about this a little bit more in the other ones. So to get you an idea of how big the wavelengths are, if we're looking at the radio side, they can be as big as buildings as far as the wave size. Or that if you get to the microwave, they're about the size of a grain of sugar. Or if you get to infrared, they're about the size of protozoans. If you get to visible, now they're about the size of bacteria. So they're getting smaller. If you go all the way to gamma rays, they're the size of an atomic nucleus, which is very, very, very small. Okay, so depending on how they work. Okay, so we need some equations that have to do with light. And there are basically three equations that we're going to be using. The first one you've probably heard of. Anybody heard of that one? We know who made that equation? That is Einstein's equation, right? Good. Okay, that's Einstein's equation. What does the E stand for? Einstein, right? Energy. Okay, what does the M stand for? Mass. And C? C is actually the speed of light. So when we talked about C, it is the speed of light. Okay, the speed of light is 3.0 times 10 to the 8th meters per second. That's pretty fast. Okay. when we talk about wavelengths, we're also talking about frequency. Frequency is how many wave peaks will pass a certain place in 1 second. Ask Banks. That's Banks. Okay. So frequency, we do this funky equation, C equals lambda nu. This is lambda. They're just Greek symbols of the alphabet. Okay, this means wavelength. And this is nu, another Greek symbol. It is frequency. So basically, frequency times wavelength will give us the speed of light. So they're related to each other.
Is that a U or C?
On which one?
Like
The C equals lambda nu. It's a C. Sorry. Okay, now we need to be able to tie these two equations together. In order to do that, we use another energy equation, E equals H nu. Nu, again, is frequency. H is what we call Planck's constant. I think there's a C. Planck's constant is a very, very small number. It's 6.6262 times 10 to the negative 34th joules divided by seconds. Okay? Now, we're not really going to ever calculate any of that in here. It would be really easy to calculate, but we're not going to do that this year. If you go on, you might. So what we've got there in the center that looks like a whole bunch of inner tubes by each other is a representation of an atom. And the shell's out from an atom. So in the center, the dark center is going to be the nucleus. And you can see that you have the visible light spectrum going down to level 2. So whenever I have something that's excited and then it falls back down to level 2, I'm going to get a visible light, something I can see. Blue, green, yellow, purple, anything I can see. If you look at the purple one there, that one's the ultraviolet. So when it falls down to level 1 from any of the other levels, I'm going to get some kind of ultraviolet ray or a gamma ray or an X-ray coming off of there. And that's the area that would be. The red area is if it falls down to just the 3rd level. Remember, these are really big waves. So if it falls down to the 3rd level, I'm going to get some kind of infrared something coming off. So it's going to be a larger wave that's coming off. Now, what you need to think about this is like this plus in the center is like the bottom floor of a building. Okay? It's like down here, 0. And as I put energy in, and energy can be heat, it can be electricity, it can be light, it can be sound. There's lots of different things that can be energy. But as I put energy in, I'm going to take the elevator up, right? Because it takes energy to move that elevator up. Same thing with an electron. It takes energy to move it out away from the nucleus. Okay, so think of it as going up flights of stairs. Okay, so I'm going to put energy in. Okay, to get up. When I come back down, I'm actually releasing energy. So energy is coming out. Okay, so on the way up, it's absorbed. On the way down, it is released. Okay, so the arrows here showing going in would be showing me releasing energy. Even though it looks like I'm putting in energy, that is actually releasing energy. Okay, because I'm going down. Coming over to the next page here, we're going to talk about ground and excited states. Now, we did the POGO on electron configuration. And when we did the POGO on electron configuration, you got to a point where you had to write an electron configuration, but it didn't feel right. It didn't feel like I've taught you how it feels. What happens is it had some extra energy, and some of those electrons were able to move. And because they were able to move, they got to what is called an excited state. It's not where we would have put them if we fill according to Aufbau, Hans, and Pauli. Okay? So a ground state is just where we should start. An excited state is where you put an amount of energy in. Now, you have to put a certain amount of energy to go from one level to another. So if I'm riding the elevator, I don't want to get from the ground floor and then get partway between the first and the second floor because I can't get off. I can't do anything. So what happens is it has to have a certain amount of energy to get to each shell or floor if you were doing it with an elevator. Once it gets to that higher level, it doesn't want to stay at that higher level because it has to have energy keep putting it in to stay at that level. So after a while it gets what I call tired and it falls back down. Okay, as it falls back down, it gives off energy. Now it can give off energy as light, as sound, as heat, as infrared rays, as UV rays, as radio waves. It can give it off a lot of different ways. So we excite it, we put energy into it. That energy has to be a specific packet in order to move from one level to the next. Then once we get to that excited state, we're up there, but after a while we get so tired that we come back down to the rest state or the ground state and give off an emission. Okay? We okay to go forward? Not yet? I tried to talk as much as I could. Okay, so the next page, what we're going to do is if you've got your Canvas up, if you'll go back to the today's date in your Canvas, so Unit 3, daily work or daily assignment stuff where it has that grid, and go down in, and it will say FET wave on a string or string wave or something like that. Go ahead and click on that, and you'll notice in your notes it asks you some questions. So I want you to play with that for a little minute. I want you to get up onto that FET, and I want you to play with it, and then write down what you found out. So, okay. So you're going to do a couple things. Up here in the upper left-hand corner, you're going to put oscillate. Okay, I want you to make sure you do that. I also want you to put fix to end. Then you can play with all this and tell me what happens in your notes, and it sort of tells you what to look at in your notes. I'm going to give you 5 minutes. So I'm going to put a timer up. You're going to have 5 minutes to play with it. We're going to come back and talk about what you found out. Go home. So go into home, go to Unit 3, daily schedule. That's daily 1. We want to do daily 3 right there. Once you get to daily 3, then go down to Monday, October, whatever it is. Keep going. And it's FET wave on a string on the right side. Okay. left, how are we doing? Are you finding stuff and writing it down? Saying what happens when you do certain things? That bottom part of that page is for you to write down what you're seeing. Make sure you're writing something down. So write down what happened when you did different things on your paper. You can play with this more later if you have some time. There is a lot of fun activities in PhET that you can go and just explore. We won't be doing all of them, but you're more than welcome to get up on PhET and just play. It's my playground. Not very smart. I did that before I turned the bell off. Okay, so if you'd finish up with what you're doing, and we're going to come back and finish the stuff that we need to know. Whoops, I didn't want to go forward. Okay, so tell me what you figured out. Somebody tell me what you found out. Something you didn't know. What happened when you did things? Yes?
When there's low tension, you there's a big pulse, it gets slower and smaller throughout the time, but when the tension's high, it stays fast and big the whole time.
Good. Okay, so she played with the tension, and when it was low, it went slower and slower as you went away from it. But it was high, it stayed the same. That's cool. Okay, what else did you find out?
The amplitude
Uh-huh.
is what makes it move like this. If there's no amplitude, then it just stays straight and slow.
Okay, so you have to have some amplitude in order to get a wave. Okay, good. What else do we find out? Yes?
The higher the frequency on the thing, the faster it made it move.
Okay, so the higher the frequency, the faster the wave moved. Okay. What else did we find out?
The higher the amplitude, the farther the dots move from each other.
Okay, the higher the amplitude, the farther the dots moved from each other. Okay, did we find anything else out? Okay, that's pretty good. You guys did a pretty good job. Okay, let's get down what we need to make sure we get out of this. So basically, whenever you had high frequency, you had short wavelength, and this is high energy. Whenever you had long wavelengths and low frequency, you had very low energy. Okay? So you need to tie the wave that you're seeing in with energy and in with wavelength and frequency. You'll notice that wavelength is either measured crest to crest or trough to trough. Okay, and who can tell me what the definition of frequency was again? What was our definition of frequency? Does anybody remember? Basically, it's how many peaks or crests or troughs pass a certain point in 1 second. Okay, so I'm looking at 1 second. How many times does this pass in 1 second? Okay, I'm either counting crests or I'm counting troughs, but how many of those pass a point in 1 second? That's frequency. Okay, so tie it together. Make sure you look at this. So if I have a higher frequency and a shorter wavelength right here, do I have high energy or low energy? High energy. If I have low frequency and longer wavelength, it's going to be low. Lower, longer, low. Higher, shorter, high. Okay? All right, so going forward, again, this is just reviewing over here, but over here we're now looking at the whole electromagnetic spectrum. There are trends. So going from gamma rays to radio waves, we have increasing wavelength. It gets bigger, the longer wavelengths. coming from radio waves back to gamma rays, we have increasing frequency. There's going to be more troughs or crests, and we have increasing energy. So if you remember from when you were in elementary school, and you had those big, long jump ropes, and you wanted to start teaching somebody how to jump rope. You did it really slow, really slow. But as you got better, what happened? You want to go faster, man, faster, faster. So it took a lot more energy if you were on the ends to get it going faster and faster, right? You got to think of it that way. Here's my really slow learning curve, and here's when I got really good, right? Okay, lots of energy. All right, we're looking now at the atom again. There's lots of different ways I can excite an electron and then bring it back down. We're not going to worry about these two bottom, the Pumfoot and the bracket series. We're just going to worry about the Paschen series. Paschen series is in the IR range. And this is how I remember it. Paschen and IR go together to make PR. PR is what if you're in a company? Anybody know? They say, we've got bad PR, we got good PR. What are they talking about?
I don't know, honestly.
Public relations, guys, public relations. So if they have public relations, how are they getting it? Through radio, TV, AM, FM radios, ways to get things out to the public. So I think, okay, Paschen, IR, that's the low waves. That's the radio waves and the AM and FM radios. Yes?
How many glasses did you want?
At least 4 to 6. Okay? All right, on this part right here, Balmer, the Balmer series is visible. This is how I remember it. Balmer, it's nice and balmy outside, and it looks beautiful, and I can see all the colors. Easy. UV, Lyman, and these go down to 1 again. This was 3, this was 2, this is 1. So Lyman, I think, okay, I'm on that balmy beach, but I'm laying out. I'm going to get a sunburn because I never tan. I just go white or sunburn. Okay? That's my life. What causes my sunburn? UV rays. That's how I remember what it is. So it's very high energy. Okay? So, a couple other words we need to know. Absorption. Absorption is when I take energy and I put it into an electron. And then that electron then moves out farther. So remember that this is the center, and these are the like the elevator, the floors going out. So in order for it to move out, I have to put energy into it. Okay, so it's moving away from the positive nucleus that wants to hold it. So it takes energy. The other word that we need to know is emission. Emission is now when I take the electron that's out here a ways, and it falls back down to its ground state because it was an excited state, and then it gives off light or heat or sound or something. Okay? So we need to know the difference between absorption, putting energy in, moving out away from the nucleus, or emission, an electron falling down closer to the nucleus and giving off energy. Okay? All right, so we are going to be doing this in lab. You're actually going to be able to see this. We're going to do it with flames for heat, and we're going to do it with electricity through cathode ray tubes filled with different gases. When we do that, you're going to be looking at them and seeing what we call a bright line spectra, which is the top one. The bottom one is an absorption spectra, but we're going to be seeing the bright line spectra. So we're going to put energy in, we're going to excite the electron up, and as the electron falls down, we'll see specific lines. Because remember, it has to go to a specific floor and come right back down. Okay? So, you're going to need to be able to look at a bright line spectra that has an unknown, and given some knowns, figure out what is in that unknown. So look at that unknown on the top, and look at the knowns down the side, and which one, or two, or three, or none, are part of that unknown. Okay, he says strontium. Is there any others? Okay, what was your clue that the strontium was in there? Okay, I can look at one thing specifically. There's 3 of these right together. And up here there's 3 of them together, right? So that's my first clue that that's probably in there. And then I look and say, oh, there's 2 over here, and there's 2 over there. It must be that. I can also look at anything else and say, there's no green, so beryllium can't be. There's no yellow, so copper can't be. Manganese has a green, so it can't be. And so does titanium, so it can't be. So I'm just looking for things that are common or not common. Very easy, right? Okay, this one is in your thing. I would like you to not shout it out, but I want you to circle the elements that are in the unknown sample. So circle the elements that are in the unknown sample. And be ready to defend yourself. Okay, with your fingers, hold up how many elements you got in the unknown sample. Okay, most of you got 2. Okay, tell me what elements they are. Oh, I got B, C, and D being yelled out. Okay, let's go through. You say for sure it's B and C. Okay, so I look here and I've got 3 lines right here. Well, these are the only 2 that have lines there. So they're going to have to be it, right? So that's a really good clue that B and C are there. Let's look at element A. It looks like it's close, but it has something here that the unknown doesn't. So because it doesn't have that, it can't be A. Now I'm looking at D. D has 2 right here that this does not have, so it couldn't be it. Can you see I'm just really quickly. Okay, mine is a little bit different than yours, so look up here for this one, and then I'll have you do yours. So what on the mixture do I have? What elements do I have in my mixture up here? I have all of them? I don't have any. Which ones do I have? Is E in there? Aren't all of them? Oh, what 3 things are you looking at? Right here? Okay, that's not here, is it? So G can't be. Okay, what about D and E?
Well, the mixture has 2 right there, but element E doesn't have 1.
Ah, good. The mixture has 2 right here, but E has 1 and D has 1, and they're close, so they both have to be in there. You see really quickly how you can change? Yeah. Look at yours. Now do yours. Yes?
Can you send those like smaller color classes, or do they have to be those?
We can use the smaller ones. Okay, what ones do you have on yours? D and Z. Good. D and Z. All right, so let's go forward here really quickly. Now, you have some empty spot on the side of your lab, so I want you to sort of write down what we're going to be doing. On our light lab, so just next to your light spectra, we have some extra room there. You don't have to do another page because you have to take pictures of these, right, and put them up. So just put it there. We're going to have what is called diffraction gratings. They look like this. Actually, they look like this. A lot of you use them for fireworks. You can put them on in fireworks. They sell them out in the summer. They're basically diffraction gratings, but they have a prism inside right here, a small prism. So they're going to separate the light, and they're going to separate the light into the lines. So you're going to be able to see the lines in lab. Okay, the bright line spectra. This one is hydrogen. You are going to, on your pre-lab, do hydrogen and boron. You're going to use colored pencils. You are going to color these lines the colors that they need to be. You're not coloring the other part that's shaded gray on your pre-lab. You're just coloring the lines. Okay? On the part where it shows the light bulb with the prism, then you're going to color the whole thing, the whole row, to show me what color they're going to be. Okay? So you're going to see something like this in lab. This one over here is an emission an absorption spectra, and you can see how hard it is. The lines are there, but they're a lot harder to see, and I can't even see the other one. It's there somewhere. So it's really hard to see when you use absorption spectra. That's why we go to line emission, because we just see what's important. Okay? So, your job. We have a test coming up. It's a term test. It is on Thursday the 25th. Next time we have a lab. If for some reason you are not going to be here for the lab and you're taking off early for fall break, we are doing the lab again next week during tutorial on Wednesday and Thursday, but you have to come to both of them because we're going to be a flame lab and a light lab. We'll do the flame lab on Wednesday and the light lab on Thursday because light lab's easier to clean up. Okay? We've all got both light and dark inside of us. What matters is what part we choose to act on. That's what we really are. This is Sirius Black from Harry Potter. So what I'm going to do is I'm going to give you about 15 minutes in each area. It's going to be a little less than 15 areas. We're going to rotate. I want to come up and have you come up here and get help if you need to. This time you can work on your independent practice. You can work on getting your lab done. Remember, you have to have your lab stamped before you leave. Okay, before you can come and do lab. So if you don't finish, you need to come during tutorial and get help and get it stamped before you have class. We already did our quiz. Make sure you upload the daily work for today, and that's all. Any questions? Okay, we'll have about 15 minutes in each one, a little less than 15. I'm going to set the timer, and then I'll come help. Red.